म्यूजिक करना नहीं आता। Good morning, everyone. I welcome you all in this session, Day 4 session of Advanced Multi-Scale 3D Modeling and Simulation of Engineering and Biomedical Research. So, I'm Pratik Bansal. I'm an application engineer in integrated microsystem and official representative of Synopsys Synthesis Software in India. Today, I'll be presenting on the topic of soft tissue and vasculature modeling with a specific focus on stents and vascular implants. This presentation is a part of advanced multi-scale 3D modeling and simulation, and today's session will explore how Synopsys Simpleware software empowers researchers and clinicians to build precise patient-specific anatomical models from medical imaging data such as CT or MRI scans. These models are vital for design, surgical planning, and simulation, especially in the cardiovascular domain where geometry and fluid dynamics are extremely sensitive to anatomical variations. We'll explore step-by-step process from image import to segmentation, feature extraction, mesh generation, and preparation for simulation or 3D printing. I'll also highlight automation tools including AI-powered segmentation that dramatically speed up this work. By the end of this talk, you should have clear understanding of how 3D imaging processing in SimpleWare facilitates high-quality, reproducible models suitable for CFD analysis, stand sizing, and static wall placement. So let's start. Let's begin with an overview of how Synopsys Synthesis software is applied in cardiovascular research and device design. Simpleware offers a complete platform for transforming medical images, especially CT and MRI scans, into detailed 3D anatomical models. These are not just visualizations, but simulation-ready geometries used in surgical planning, implant design, and hemodynamic simulations, such as computational fluid dynamics. One of the standout features is its ability to support patient-specific modeling, meaning that every model can represent an individual patient's unique anatomy. This is critically important in cardiovascular applications because even minor variations in vessel diameter or wall geometry can significantly impact outcomes when placing a stent or wall implant. Simpleware integrates both manual and AI-driven segmentation techniques. This combines users to go from raw images to clean labeled and matched 3D models with minimal effort. The software also supports advanced tools like automatic landmark detection, wall plane fitting, and vessel central line extraction, all of which are vital for accurate stand positioning and blood flow simulations. In essence, the software simplifies a complex and time-consuming workflow into an efficient, reproducible process. Whether you are a biomedical researcher, a clinical engineer, or a medical device designer, Simpleware helps streamline tasks that would otherwise require hours of manual processing, ensuring faster turnaround and greater precision. So let's begin with importing data. Now that we are understand that broader applications of simpleware in cardiovascular domains, let's walk through the actual workflow. The first step in any modeling process is important. It is importing the medical scan data, most commonly in the DICOM format. Simpleware provides native support for importing DICOM datasets directly. When you bring in a scan, the software automatically detects the orientation of the image series and organizes them consistently for downstream processing. Whether you are working with CT, micro CT, MRI, or other medical modalities, Simpleware ensures that the imported dataset is both accurate and well structured. Once imported, you can easily visualize the dataset in both 2D and 3D viewers. This means scrolling through axial, sagittal, and coronal slices while also being able to interact with the volumetric render in 3D. These dual capabilities allow clinicians and engineers to get a comprehensive understanding of patients' anatomy before any segmentation begins. It's also worth noting that Simpleware allows multi-scan modalities to be loaded together for multi-contrast or multi-resolution analysis. For instance, CT data might be used for high-resolution bone segmentation, while MRI might be better for soft tissues, details like vessels or myocardium. This flexibility is especially useful when modeling complex cardiovascular structures like bifurcated arteries or wall leaflets, where the multimodal imaging can improve fidelity. So the import process is not just a file loading task, it is an important step where Simpleware prepares your dataset for clean, streamlined, and high quality segmentation and analysis. This is the foundation upon which all subsequent modeling processes are built. Once your DICOM data is successfully imported, the next logical step is to understand how to navigate the dataset using both 2D and 3D views. Simpleware offers a highly intuitive viewers interface that allows users to inspect the medical image data across multiple planes, that is axial XY plane, coronal YZ plane, and sagittal XZ plane. These slice views help in understanding anatomical positioning and are especially crucial in cardiovascular modeling where precision is a key. You can scroll through the slices, adjust the slice thickness, and change the display range to better visualize subtle anatomical structures. The system also lets you link the views together, so when you click on a region in one slice, the other views automatically synchronize to show the corresponding anatomy. In addition to 2D slices, SimpleWare's real-time 3D rendering provides a volumetric representation of image data. This view can be rotated, zoomed, and sliced through interactively. It allows users to gain spatial context. Am I audible? Earphone है लेकिन उसमें ठीक है. Hmm?
Oh, everyone just speaking while this is a particular earplugs.
मुझे बताना आवाज आ रही है. Hello, am I
Hello,
audible?
am I audible now? Okay.
So I was
So
on.
I was on, like, you
Scroll
can
through the
scroll through
slices,
the slices, adjust the slice thickness, and change the display range to better visualize subtle anatomical structures. The system also lets you link the views together, so when you click on region in one slice, the other views automatically synchronize to show the corresponding anatomy.
In
In
addition,
addition,
The
Uh,
2D slices
2D
simple
slices
when
simple where
3D and
real-time
3D
3D
provides
rendering
a
provides a
volumetric
volumetric
representation of
representation of
image data.
image data.
This view
This
can be
view can
rotated,
be
zoomed,
rotated,
and
zoomed,
sliced
and sliced through interactively.
it allows
It
users
allows
to
users
gain
to
spatial
gain spatial
context,
context,
which
which
is
is
very
very
important
important
when
when
dealing
dealing the
the 3D
3D
structures
structures
like the
like
aortic
the
arc
aortic arch
or the
or
curvature
the
of
curvature
coronary
of
artery.
coronary arteries.
Being able to
Being able
toggle
to
between
toggle
2D and
between 2D
3D
and 3D
gives you a
gives you a
flexibility to
flexibility to
analyze the
analyze
heart
the
and
heart and
vascular
vascular from both
and
microscopic and
macroscopic levels.
macroscopic perspective.
This is
This is
essential for
essential
tasks
for
such as
tasks such as
defining valve
defining valve
orientations,
orientations,
identifying
identify
vascular
vascular
branching,
branching,
and measuring
or
distance
measuring distance
between
between
clinical and
clinical and
anatomical
anatomical
landmarks.
landmarks.
Moreover,
Moreover,
these
these
views are not
views
just
are not just
visualizations, they
visualizations,
serve
they
as
serve as
interactive
interactive
environments
environments
where you can
where you can
perform
perform
tasks like
tasks like
landmark
landmark
placement,
placement,
thresholding,
thresholding,
segmentation,
segmentation,
validation, and
validation,
measurement
and measurement
abstraction,
abstraction,
all in real
all
time.
in real time.
Ultimately,
Ultimately,
mastering the 2D
mastering the
and 3D
2D and 3D
visualization tools in
visualization tools in
simpleware
simpleware
lays the
lays the
groundwork for
groundwork for
accurate,
accurate,
clinically relevant
relevant
cardiovascular
cardiovascular
models.
models.
Next, coming
Next,
to
coming to
grayscale
grayscale
calibration and
calibration and
contrast
contrast
settings.
settings.
So once the
So
image
once the
data is
image data
loaded
is
and
loaded
views are
and views are
configured,
configured, the next essential
is
steps is to
calibrating
calibrating
the
the
grayscale and
grayscale and
adjusting the
adjusting
contrast
the
settings.
contrast settings.
These
These
adjustments
adjustments
significantly improve
significantly
the
improve the
visibility of
visibility
soft
of
tissues
soft tissues
such
such
as
as
arteries,
arteries,
myocardium,
myocardium,
and
and
heart chambers.
heart chambers.
Simpleware provides
Simpleware provides
flexible windowing
flexible
tool,
windowing tool,
enhance image
enhance
contrast,
image contrast,
adjusting the
adjusting
window,
the window,
refers to
refers
modifying
to
the range
modifying
of
the range
housing
of
unit.
housings unit.
For
For
cardiovascular
cardiovascular
applications,
applications,
setting the window
setting the
level
window level
correctly
correctly is
is
crucial,
crucial,
especially when
especially when
attempting to
attempting to
visualize
visualize
low
low
contrast
contrast
tissues
tissues
like
like coronary
coronary
arteries.
arteries.
The software
The
also
software
includes
also includes
predefined presets
predefined
such as
presets such as
coronary
coronary
arteries gray,
arteries gray,
which
which
are
are
optimized for
optimized for
cardiac
cardiac
visibility. These
visibility.
settings are
These
designed
settings
to
are
help
designed to help
clinicians
clinicians
and
and
engineers to
engineers
enhance
to
the
enhance
image
the
for better
image for better
segmentation.
segmentation.
Performance without
Performance
trial
without
and
trial
error,
and error,
manual tuning.
manual tuning.
Proper contrast
Proper
settings
contrast
are
settings
not
are
only
not
about
only
clarity,
about
they
clarity,
directly
they
influence
directly influence
segmentation's
segmentation's
accuracy.
accuracy.
A well
A well
contrasted scan
contrasted scan
ensures that
ensures that
thresholding tools can
thresholding tools can
precisely
precisely
isolate
isolate
anatomical features
anatomical
based on
features based on
grayscale
grayscale
intensity.
intensity.
They can be
They
saved
can be
and
saved
applied
and
to
applied
future
to
scans.
future scans. The
Standardization
standardization
ensures
ensures
consistent model
consistent model
quality across
quality
different
across
patients
different
or time
patients or
points.
time points.
In summary,
In
grayscale
summary, grayscale
calibration
calibration
and
and
contrast
contrast
optimization are
optimization are
foundation
foundation
steps
steps that
precedes any
precedes
form of
any form of
segmentation.
segmentation.
They help
They
reveal
help reveal
anatomical boundaries
anatomical
clearly,
boundaries
enable
clearly,
accurate
enable accurate
thresholding, and
thresholding, and
ultimately lead to
ultimately lead
more
to
precise
more precise
and
and
clinically
clinically
meaningful 3D
meaningful
models
3D
of
models for
cardiovascular systems.
cardiovascular systems.
With the image
With the
data
image
clean
data
and
clean and
optimized through
optimized through
contrast
contrast
adjustment
adjustment
and median
and
filtering,
median
we are
filtering,
now
we are
ready to
now ready
begin
to
with
begin with
segmentation process.
segmentation process. One of the foundation techniques used here
Threshold
is
based
threshold-based
segmentation.
segmentation.
Thresholding works by
Thresholding works by
isolating pixel
isolating pixel
intensities within a
intensities within a
specific range,
specific range,
which usually
which usually
corresponds to house
corresponds to
fields
house
unit
fields unit
in CT
in
data
CT
or
data
signal
or signal
intensities
intensities
like MRI.
like MRI.
In
In
cardiovascular
cardiovascular
applications,
applications, different
such
tissues
as
such
blood,
as blood,
myocardium, or
myocardium, or
calcified plaque
calcified plaque
present
present
different
different
intensity values.
intensity values.
This makes
This makes
thresholding a
thresholding a
powerful tool
powerful tool
for
for
distinguishing and
distinguishing and
isolating these
isolating
regions.
these regions.
In
In
simpleware,
simpleware,
you can
you
manually
can
or
manually or
automatically define
automatically
a range
define
of
a range
grayscale
of
values
grayscale values
that match the
that match the
intensity of your
intensity
target
of your
issue.
target issue.
For
For
instance, if you
instance,
want
if
to
you want
segment
to
the
segment
aorta
the aorta
or the left
or the left
ventricle, you can
ventricle, you
select
can
the
select the
threshold range that
threshold range that
corresponds to the
corresponds
blood
to the
region.
blood-filled
The
regions.
software
The
will then
software will
highlight
then highlight
and mask all
mask all
voxels
voxels
that fall within
that
this
fall
range.
within this range.
What's
What's
impressive is
impressive
that
is that
Simpleware allows
Simpleware
real-time
allows
review
real-time
of your
preview of your
threshold mask.
threshold mask.
As you
As
tweak
you
the
tweak
values,
the
you
values, you
immediately see
immediately
how the
see how the
segmentation
segmentation
evolves,
evolves,
enabling
enabling iterative refinement.
This makes
This
it much
makes it
easier to
much
capture
easier to
fine
capture
structures
fine
like
structures like
platelets,
platelets,
coronary
coronary
arteries.
arteries, or even calcium crystals.
Our
However,
threshold
thresholds
alone may capture
alone may capture
unwanted
unwanted
regions
regions
that share
that
similar
share similar
intensities,
intensities, such as
such
adjacent
as
chambers
or nearby
or
vessels.
nearby vessels.
Address this
Address this
thresholding is
thresholding is
typically used
typically
as
used
a first
as a
step
first
followed
step
by
followed by
morphological
morphological
tools like blood
tools like
fills,
blood fill,
region fitting,
region
or
splitting,
connected
or connected
components.
component analysis.
To define the
To refine
selection.
the selection,
Overall,
overall,
threshold-based
threshold-based
segmentation in
segmentation in
simpleware provides
simpleware
an
provides an
efficient,
efficient,
user-friendly
user-friendly way to gauge
initial
the
mass
initial mass
of the heart
of the
vessel.
heart vasculature.
It's
It's
specifically
specifically
effective when
effective
paired
when
with
paired with
optimized grayscale
optimized
settings
grayscale settings
and
and
pre-processing
pre-processing
filters,
filters,
laying the
laying the
groundwork for
groundwork
precise
for precise
anatomical modeling
anatomical
and
modeling and
simulations.
simulations.
Following
Following
thresholding, the next
thresholding, the
critical
next
step
critical
is
steps
refining
is
your
refining your
segmentation
segmentation
using
is
flood
using
fill
flood
tools.
fill tools.
Thresholding alone
Thresholding alone
often captures
often captures
extra
extra
disconnected elements
disconnected
with
elements with
simple
simple
intensity values,
intensity values,
especially in
especially
complex
in complex
anatomical
anatomical
regions like
regions
the heart.
like the heart.
This is where
This is
flood
where
fill
blood
becomes
fill becomes
invaluable.
invaluable.
It helps
It helps
isolate
isolate
only the
only the
connected regions
connected
that
regions
are
that are
anatomically relevant.
anatomically relevant.
Flood fill in
Flood fill
simple
in
way
simple
works
way
by
works by
starting from a
starting
seed
from a
point.
seed point that
Users select
users select
typically in the
typically
center
in
of
the
the
center of
target.
the target.
Structures like
Structures
aorta
like
or a
aorta
heart
or a
chamber.
heart chamber.
Algorithm then
Algorithm
include
then
the
include only the
voxels
voxels
that are not
that are
only
not
within the
only within the
grayscale range
grayscale range
but are also
but are
connected to
also
the seed.
connected to the seed.
This removes
This
any
removes any
floating or
floating or
disconnected
disconnected
artifacts
artifacts
that
that
were
were
mistakenly
mistakenly
captured during
captured during
thresholding.
thresholding.
Let's take an
Let's
example.
take an
When
example. When
segmenting
segmenting an
ascending aorta,
ascending aorta,
a
a
threshold mask
threshold
might
mask might
also capture
also
part
capture
of
part of
descending aorta,
descending aorta,
pulmonary
pulmonary
artery, or
artery,
even
or
cardiac
even
chambers
cardiac chambers
due to
due
similar
to similar
intensity
intensity
values.
values.
Using
Using
flood fill
flood
form,
fill form,
the root of
the route of
ascending aorta
ascending
will
aorta will
exclude those
exclude those
distant
distant
but
but
similarly
similarly
intense regions,
intense regions,
isolating a
isolating
clean
a clean
connected structure.
connected structure.
Flood fills
Flood
is
fills is
especially effective
especially
in
effective
vascular
in vascular
applications
applications
where
where
you need
you need
precise
precise
marks of
marks of
tabular
tabular
containers
container
structures.
structures.
It
It
ensures
ensures
anatomical
anatomical
accuracy and
accuracy and
minimizes the
minimizes the
effort
manual
of
effort
cleaning
of cleaning
the mask
the
post
mask
threshold.
post threshold.
3D
The
rendering
3D
of the
rendering of
flood
the
filled
flood
region
filled region
helps validate
helps
the
validate the
segmentation.
segmentation in real time.
If
If
necessary,
necessary,
the
the
seed
seed
point can
point
be
can be
repositioned
repositioned
and the
and the
algorithm
algorithm
rerun for better
rerun for better
accuracy.
accuracy.
This kind
This
of
kind of
feedback
feedback
loops
loops
ensures that
ensures
even
that even
novice
novice
users
users
can
can
confidently perform
confidently
precise
perform precise
segmentation.
segmentation.
To sum up,
To sum up,
flood fill
flood fill
segmentation
segmentation in simple way
refines the
refines
mask
the
by
mask by
enforcing
forcing
anatomical
anatomical
connectivity,
connectivity,
avoiding
a vital
precise
precise
for creating
for creating
simulation ready
simulation ready
cardiovascular
cardiovascular
models.
models.
Next, we'll look
Next, we'll
further
look
in
further in
segmentation
refining
using
segmentation using
region splitting,
region splitting, particularly for isolate the
and
aorta or
neighboring
neighboring
structure.
structure.
So after
So
applying
after
flood
applying
fill to
flood fill
capture
to
only
capture only
connected
connected
structures, the
structures,
next
the
step
next
is
step is
simple
simple-based split
regions tools.
regions tools
To further
to further
isolate
isolate
specific
specific
anatomical
anatomical
elements,
elements,
particularly
particularly
aorta, which is
aorta,
often
which is often
embedded within
embedded
a
within a
larger mass
larger mass
containing nearby
containing nearby
cardiovascular
cardiovascular
structures.
structures.
Splitting regions
Splitting
allow
regions
you to
allow you
separate
to separate
components of a
components of
mass
a
that
mask
are
that
still
are
part
still
of the
part of
same
the same
blood fill,
blood fill
but
but
represent
represent
distinct
distinct
anatomical
anatomical
entities.
entities.
For
For
instance,
instance,
in
when
segmenting the heart,
segmenting the heart,
the mask
a
might
mask
still
might still
include
include
parts of
parts of
pulmonary
pulmonary
artery,
artery,
left
left
ventricle,
ventricle,
or even
or
the
even the
atria,
atria,
along with
along
aorta.
with aorta.
This tool
This
helps
tool
in
helps in
dividing these
dividing these
structures
structures
and
cleanly
retaining
and
only
retaining
the
only the zone of
regions.
interest.
In simple
In
way,
simple
this
way,
is
this is
done
done
interactively.
interactively.
You can
You
place
can
paint
place
markers
paint markers
on the
on
different
the
regions
different
of the
regions of
mask.
the mask.
Uh,
Uh,
say one of
Say
the
one of the
descending
descending
order
aorta, another,
on the other
and the
another is
another is
adjacent system.
adjacent structure.
The software
The
then
software
uses
then
these
uses
markers
these
to
markers to
automatically
automatically
divide the
divide
mask
the
into
mask into
independent
independent
connected
connected
components.
components.
The result
The
is a
result
set
is a
of
set
split
of split
regions,
regions,
each
each of which can
can
be
be individually
individually
selected,
selected,
labeled,
labeled,
and saved.
and saved.
Once the
Once the
aorta is
aorta is
isolated as a
isolated as
separate
a
region,
separate
it
region,
becomes
it
much
becomes
easier
much
to
easier to
perform
perform
measurements,
measurements,
extract center
extract
lines, or
center lines,
prepare
or
a
prepare
mesh
a
generation.
mesh generation.
This
This
process is
process is
particularly
particularly
crucial for
crucial
stand
for
design
stand design
or
or
placement,
placement,
where only the
where only the
aorta needs
aorta
to be
needs to be
simulated or
simulated
3D.
or 3D printed.
It's
It's
also
also
worth noting
worth noting
that split
that
regions
split
can be
regions can be
visually
visually
inspected
inspected in
in
both
both
2D
2D and
and
3D
3D
viewers.
viewers.
You can toggle
You can toggle
visibility,
visibility,
apply color
apply
coding,
color
and
coding, and
verify
verify
geometry
geometry before
before
proceeding
proceeding.
further.
In summary,
In summary,
the split
the
region
split
tools
region tools
enhances
enhances
segmentation
segmentation
accuracy by
accuracy by
providing fine
providing fine
control
control
over mask
over mask
positioning.
positioning.
This level of
This level
control
of
is
control is
in
in
cardiovascular modeling,
cardiovascular modeling,
where,
where,
indiv-
indiv-
where
where
individual
individual
structures must
structures
be
must
often
be
by
often
modeled
by
and
modeled and
analyzed
analyzed
separately for
separate for
diagnostic
diagnostic or
therapeutic planning.
therapeutic plan.
Let's now
Let's
move on
now
to
move on to how
how
Simpleware
accelerates the
accelerates the
segmentation process
segmentation
using
process using
automated tools
automated
for
tools
heart
for
safety.
heart CT.
So having
So,
seen
having
the manual
seen the manual
segmentation
segmentation
workflows
workflows
using
using
thresholding,
thresholding,
blood pills,
flood
and
pills,
region
and
splitting,
region splitting,
we are now
we are
moving
now
to
moving
the most
the
saving
most saving
features.
features.
Simpleware, the
Simpleware, the
automated tool
automated
for heart
tool for
safety.
heart rate.
Manual
Manual
segmentation, while
segmentation, while
accurate, can be
accurate, can
time
be
consuming
time consuming
and labor
and labor
intensive,
intensive,
especially when
especially
dealing with
when
the
dealing with
complex
the complex
structures like
structures
heart
like
chambers,
heart chambers,
major
major
vessels,
vessels,
and
and
myocardium.
myocardium.
Simpleware's heart
Simpleware's
safety
Heart
module
CT module
automates this
automates
process
this
using
process using
AI
AI-enhanced algorithms
that are
that
trained
are
to
trained to
recognize
recognize the
cardiac
segment card anatomy
quickly
quickly
and
and
reproduce.
reproducible.
The tool
The tool
identifies
identifies and
major
separates major
anatomical
anatomical
regions of the
regions of
heart
the
from
heart
CT
from CT
scans,
scans,
including the
including
left
the left and right
ventricle,
ventricles,
atria,
atria,
aorta,
aorta,
pulmonary artery,
pulmonary
and
artery, and
myocardium.
myocardium.
With just
With just
few
few
clicks, it
clicks, it
generates labeled
generates
mask
labeled
for
masks
each
for
of these
each of
parts,
these parts,
dramatically
dramatically
reducing
reducing
the
the
manual
manual
effort
effort
required
required
and
and
minimizing
minimizing
inter-user
inter-user
variability.
variability.
The strength
The
of
strength
this
of
tool
this tool
lies in its
lies in its
ability to
ability to
maintain
maintain anatomical
accuracy while
accuracy while
streamlining
streamlining
workflows,
workflows,
especially
especially
beneficial in
beneficial
cases
in cases
where
where
multiple
multiple
datasets need to
datasets
be
need to
processed.
be
For
processed. For
instance,
instance,
in
in
clinical
clinical
studies or
studies
when
or when
preparing
preparing
patient-specific
patient-specific
models
models
for a
for
series
a
of
series of
individuals.
individuals.
Another key
Another key
advantage is that
advantage is
this
that this
automated
automated
segmentation is
segmentation
fully
is fully
editable.
editable.
Once
Once
generated, you
generated,
can
you
still
can still
inspect,
inspect,
adjust, or
adjust, or
refine
refine
each
each
region
region using
standard
standard Simpleware
manual tools.
manual tools.
This gives you
This gives you
flexibility to
flexibility to
fine-tune
fine-tune
areas like
areas like
walls,
wall faces,
coronary
coronary
ostia,
ostia,
or
or
regions with
regions
image
with image
artifacts without
artifacts without
starting from
starting from
scratch.
sketch.
The Heart
The
City
Heart
module
City module
not only
not
saves
only
time
saves time but
but
also
enhances
enhances
standardization
standardization and reproducibility,
which are
which
critical
are
in
critical
both
in both
clinical and
clinical and
regulatory
regulatory
settings.
settings.
When you are
When you are
designing a
designing a
stent
stent
for the
for
aortic
the
arch
aortic arch for
simulating blood
simulating
flow,
blood flow through left ventricle,
this tool
this tool
ensures you are
ensures you
starting
are
with
starting with
a
a
consistent and
consistent and
anatomical
anatomical precise model.
in the next
In the
slide,
next slide,
we
we'll
explore how you
explore
can
how you can
select
select
specific
specific
cardiac parts
cardiac
for
parts for
segmentation
segmentation,
depending on your
depending on
simulation
your simulation
objectives.
or routing objectives.
One of the
One of
most
the
powerful
most powerful
aspects of
aspects of
Simpleware's hard
Simpleware's
CD
Hard
module
CD module
is the
is the
ability to
ability to
select
select
specific cardiac
specific
parts
cardiac
for
parts for
segmentation.
segmentation.
Based on your
Based on
modeling
your
or
modeling or
simulation goals,
simulation goals,
this feature
this feature
introduces a
introduces a
level of
level of
flexibility
flexibility
that is
that is
essential in
essential in
cardiovascular research
cardiovascular
and
research
device
and
planning.
device planning.
Not every
Not
project
every project
requires
requires
full heart
full heart
segmentation.
segmentation.
For example,
For
a
example,
study
a
on
study
wall
on wall
placement
placements
may only
may
need
only need
detailed models
detailed
of the
models of the
aortic
aortic
roots and
roots and
leaflets,
leaflets,
while
while
fluid
computational
dynamic
fluid dynamic
simulations
simulations
may
may
focus on the
focus
left
on the left
ventricle
ventricle and
outflow tract.
outflow tract.
Simpleware allows
Simpleware
users
allows
to
users
tailor
to
their
tailor their
segmentation
segmentation to
only the
only
relevant
the
structures,
relevant structures,
saving time,
saving time,
reducing data
reducing
size,
data
and
size,
improving
and improving
computational efficiency.
computational efficiency.
When using
When
hard
using
CP
hard
tools,
CP tools,
users can
users
check
can
or
check
exclude
or uncheck
boxes,
boxes,
include or
include or
exclude
exclude
specific
specific
components
components
such as
such as
left
left
ventricle,
ventricle,
right
right
ventricle,
ventricle,
atria,
atria,
myocardium,
myocardium,
aorta,
aorta,
pulmonary,
pulmonary artery,
coronary
coronary
arteries.
artery.
This
This
customization
customization
extends to the
extends to
level
the
of
level of
detail
detail
as well.
as well.
For
For
example,
example,
you may
you
choose
may
to
choose
segment
to
the
segment
aortic
the aortic
up to the
up to the
sinotabular junction
sinotabular
or
junction or
include the
include
full
the
aortic
full
arc
aortic arc
depending on the
depending on
stent
the stent
or wall
or
placement
valve
location.
placement location.
Such
Such
modular
modular
segmentation is
segmentation is
especially helpful
especially helpful
when dealing with
when dealing
limited
with limited
computational
computational
resource
resource
or when
or when
targeting
targeting
specific
specific
clinical
clinical
questions.
questions.
Also
Also
enhances
enhances
patient-specific
patient-specific
models by
model by
allowing
allowing
ingenious
ingenious
interventions
inclinations
isolate
isolate
in-study
in study
regions
regions
most affected
most
by
affected by
pathology
pathology
like
like a
unnarrowed
neurotic
aortic
aortic
wall
wall
or
or
dilated
dilated ventricle.
finally.
Finally,
These
these
segmented parts
segmented
can be
parts can be
exported
exported
separately
separately
or
or
as part
as
of an
part of an
integrated model,
integrated model,
and each
and
retains
each
its
retains
label
its
in
label in
metadata.
metadata.
This makes
This
them
makes them
readable,
readable,
for
usable for
meshing,
meshing,
simulation, or
simulation,
even
or
3D
even
printing.
3D printing.
After
After
selecting the
selecting the
specific cardiac
specific
parts
cardiac
to
parts
segment,
to segment,
the next
the
step
next
in
step in
enhancing the
enhancing the
anatomical model
anatomical model
involves
involves
automatic
automatic
detection of
detection of
anatomic
anatomic
landmarks,
landmarks,
particularly
particularly
around heart
around
valves
heart valves
and
and
chambers.
chambers.
These
These
landmarks serve
landmarks
as
serves
vital
as
reference
vital
points
reference
for
points for
both
both
diagnosis and
diagnosis and design.
SimpleWare's
Simpleware's
automated
automated
landmarking
landmarking feature
identifies and
identifies
labels
and
key
label key
anatomical features
anatomical
such as
features such as
valve
valve
cups,
cups,
aortic,
aortic,
mitral,
mitral,
pulmonary,
pulmonary,
tricuspid,
tricuspid,
coronary
coronary
ostia,
ostia,
ventricular
ventricular
apex,
apex,
annular
annular
planes,
planes,
left
left
ventricle
ventricle
outflow tract.
outflow tract.
Important of
Important
these
of these
landmarks
landmarks
cannot be
cannot be
overstated.
overstated.
For
For
instance,
instance,
when
when
planning
planning
aortic valve
aortic valve
implantation,
implantation,
you need
you
accurate
need
location
accurate
of the
location of
aortic
the aortic
annulus and
annulus and
coronary ostia.
coronary ostia.
Ensure
Ensure
prostatic valve
prostatic
does
valve
not
does
block
not block
blood flow
blood
to the
flow to the
coronary
coronary
arteries.
arteries.
Position
Position
of the
of the
mitral
mitral valve annulus
critical
is
in
critical in
central
mitral clip
procedures.
procedures.
The landmark
The landmark
detection
detection
algorithm in
algorithm in
SimpleWare
Simpleware
uses trained
uses
models
trained models to
with
recognize
geometric
geometric
patterns.
and intensity patterns.
Once
Once
detected,
detected,
landmarks are
landmarks are
overlaid in
overlaid
both
in both
2D and
2D
3D
and 3D views,
allowing
allowing for
quick visual
quick visual
confirmation if
confirmation
needed.
if needed.
Users can
Users
manually
can
adjust
manually
these
adjust
points,
these
giving
points,
full
giving full
control to the
control to
operator.
the operator.
These
These
landmarks also
landmarks
play a
also play a
foundation role
foundation
in
role in
downstream
downstream
workflows,
workflows,
including
including
wall plane
wall
fitting,
plane fitting,
measurement of
measurement
distance
of
between
distance between
anatomical
anatomical
features,
features,
center line
center
and
line
flow
and
path
flow path
extraction,
extraction,
simulation mesh
simulation mesh
alignment.
alignment.
Moreover,
Moreover,
once placed,
once placed,
landmarks can be
landmarks can be
exported as
exported as
coordinate
coordinate
live
live
or
or
integrated into
integrated into
simulation
simulation
environments such as
environments such as
ANSYS or
ANSYS
COMSOL.
or consoles.
In
In
essence,
essence,
this step
this
brings
step brings
anatomical
anatomical
intelligence
intelligence
into the
into
model,
the model,
enabling precise
enabling precise
alignment,
alignment,
orientation, and
orientation, and
customization.
customization.
It saves
It saves
hours of
hours
manual
of
effort
manual
and
efforts and
improves model
improves model
accuracy.
accuracy.
Two pillars
Two
of
pillars of
reliable
reliable medical
simulation.
device simulation.
In the next
In the
section,
next section,
we'll see
we'll
how
see
landmarks
how
are used
landmarks
in
are used
calculate
in calculate
distance.
distance.
So after
So after
identifying the
identify
wall
the valve
anatomy,
anatomy,
measuring distance
measuring
in
distance
coronary
in coronary
ostia,
ostia,
the next
the
logical
next
step
logical
is
step is
functional
valve-specific
analysis.
functional analysis.
In simple
In
way,
simple
this
way,
means
this means
selecting a
selecting a
particular heart
particular
valve
heart valve
such as
such as
aortic,
aortic,
mitral,
mitral,
pulmonary, or
pulmonary, or
tricuspid
tricuspid
for
for
focused modeling
focus
and
modeling and
simulation
simulation
preparation.
preparation.
When a
When a
valve is
valve
selected,
is selected,
SimpleWare's
SimpleWare's
interface
interface
adjusts
adjusts
present
present
tools and
tools and
visualizations
visualization
specific to the
specific
valve.
to that valve.
This modular
This
approach
modular
helps
approach helps
users
users
align the view
align
with
the
the
view
valve
with the valve
axis, which
axis,
plays
which
to
pertains
annular
to
and
annual,
valve
annuli, or
cups.
cups.
Extract key
Extracts key
measurements like
measurements like
orifice
orifice
diameter,
diameter,
leaflet thickness,
leaflet thickness,
and annual
and
geometry.
annual geometry.
For example,
For
if
example,
you choose
if you
aortic
choose
wall,
aortic wall,
the software
the software
highlights
highlights aortic
annulus
annulus
and valve
and
cups,
valve cups,
enabling you
enabling
to
you
define
to
planes
define
that
planes that helps
helps tilt,
assess tilt,
eccentricity,
eccentricity,
calcium
calcium
distribution.
distribution.
These
These
critical
critical
parameters when
parameters
selected
when selecting and placing
are
a
transcatheter.
transcathelar.
You can
You
also
can
define
also define
cross-sectional
cross-sectional
planes at the
planes at the
base,
base,
midsection, and the
midsection,
top
and the
wall
top
to
wall
measure
to measure
dimensions,
dimensions,
detect
detect
asymmetry, or
asymmetry, or
simulate
simulate
prosthetic seating.
prosthetic seating.
These
These
insights
insights guides decisions
the
about
shape
the
of
shape of
size of
size of
prosthetic wall,
prosthetic wall,
how it should be
how it should
oriented
be
to
oriented to move,
paravalvular
paravalvular
leakage,
leakage,
whether patient
whether patient
anatomy is
anatomy is
compatible
compatible
with
with
off-the-shelf
off-the-shelf
customer
or
solution.
customer solutions.
This
This
functionality is
functionality is
also
also
valuable for
valuable for
prosthetic
prosthetic
heart wall
heart wall
designers
designs
who need to
who need
validate
to validate
that their
that their
device fits
device fits
diverse
diverse
anatomical
anatomical
variations.
variations.
The data
The
gathered
data gathered using
this
this
valve-centric
valve-centric
analysis
analysis
is
is
exportable to
exportable
CAD,
to CAD,
finite element
finite element
analysis,
analysis,
computational fluid
computational fluid
dynamics,
dynamics
workflows,
workflows,
ensuring
ensuring
seamless
seamless
integrations
integrations
with
into your
downstream
downstream pipe.
pipelines. Now, once
Now,
a
once a
specific heart
specific
valve is
heart valve
selected
is selected
for
for
analysis,
analysis,
the next
the
essential
next
task
essential
is
task
fitting
is
a
fitting
valve
a valve
established a
establish a
geometric reference
geometric
frame.
reference frame.
This frame
This
helps
frame
define
helps define
orientation and
orientation
alignment
alignment
of the wall
of the wall
with
with
respect to
respect to
surrounding
surrounding
targets,
cardiac structures,
which is
which
critical
is
for
critical
both
for both
simulation
simulation
accuracy and
accuracy
device
and
integration.
device integration.
In simple
In
way,
simple way,
wall planning
wall
fitting
planning
is
fitting is
typically performed
typically
using
performed using
anatomical
anatomical
landmarks
landmarks
such as wall
such as
cuts,
valve cups,
annuli, and
annuli,
ostia
and ostia
that are
that
either
are either
auto-detected or
auto-detected
manually
or
placed.
manually placed.
The software
The
then
software
fits a
then fits a
geometric plane
geometric
which
plane
passes
that
through
passes
these
through
reference
these
points,
reference points,
creating a
creating a
consistent
consistent
orientation for
orientation for
measurements
measurements
and
and
downstream
downstream
tasks.
tasks.
For
For
instance,
instance,
fitting a
fitting a
plane across
plane
the
across the
acoustic
acoustic
annulus
annulus
allows you to
allows you to
establish a
establish
clear
a
cutting
clear cutting
plane
plane
for
for
cross-sectional
cross-sectional
measurements
measurements
to find the
to
normal
find the
vector
normal
for
vector for
aligning
aligning
prosthetic valves,
prosthetic valves,
generate
generate
inlet-outlet
inlet
or
outlet outlet
faces,
basis for
computational fluid
computational
dynamics
fluid dynamic
simulations.
simulations.
This
This
orientation is
orientation
also
is
vital
also
in
vital in
procedures like
procedures like
TAVI,
TAVI,
where the
where the
development axis
development
of
axis
the wall
of the
stand
valve
must
stand
align
must align
precisely with the
precisely with the
patient's
patient's
native
native
aortic
aortic
axis to
axis
avoid
to
tilting
avoid
and
tilting as
asymmetric
asymmetric
expansion.
expansion.
Once the plane
Once
is
the plane
fitted,
is fitted,
it can be
it can be
visualized in
visualized
both
in both
2D and
2D
3D
and
viewers,
3D viewers,
and the
and the
orientation can be
orientation can
docked
be
or
docked
added.
or edited.
This gives
This
user
gives user
flexibility to
flexibility to fine-tune
based
placements
on
based on
clinical or
clinical requirements
device
or device
constraints.
constraints.
Moreover, these
Moreover,
planes
these
serve as
planes serve as
references
references
for clipping
for clipping
volumes,
volumes,
3D
for
printing
3D
or
printing
meshing,
or meshing,
simulation boundaries
simulation
for fluid
boundaries
or
for fluid
structure
or structural
analysis,
analysis,
coordinate
coordinate
systems for
systems
motion
for
tracking
motion
or
tracking
dynamic
or dynamic
simulation.
simulations.
In
In
summary, wall
summary,
plane
wall
fitting
plane fitting
transforms a
transforms a
segmented wall
segmented
into a
wall
fully
into a
oriented
fully oriented
context-aware model,
context-aware model,
enabling more
enabling more
accurate
accurate and
customizing planning,
customizing planning,
design, or
design,
simulation
or simulation
workflows.
workflows.
Next, we'll
Next,
explore
we'll
generating
explore generating
arteries, central
arteries,
lines,
central lines, which are
crucial for
crucial for
modeling vascular
modeling
paths
vascular
and
paths and
understanding flow
understanding flow
geometry.
geometry.
With valve
With valve
orientation
orientation
established,
established,
we
we
now move
now
on to
move on
another
to
essential
another
component,
essential component,
cardiovascular modeling,
cardiovascular modeling,
that is
that is
arterial center
arterial
lines.
center lines.
These
These
lines
lines
trace the
trace
geometry
the
center
geometry
of
center
blood
of blood
vessels,
vessels,
effectively
effectively
capturing their
capturing
flow
their
paths,
flow paths,
curvature, and
curvature,
branching
and
structure.
branching structure.
In simple
In
way,
simple way,
generating center
generating
line
center
is a
line is a
semi-automated
semi-automated
that
process
begins
that
with a
begins with a
segmented
segmented
vessel mass,
vessel mass,
typically the
typically
aorta,
the aorta,
coronary
coronary
arteries, or
arteries, or
peripheral
peripheral
vasculature.
vasculature.
The software
The software
extracts center
extracts
line by
center line
tracing
by tracing
the
through
midpoint
the
of
midpoint
lumen
of lumen
from
from
inlet to
inlet
outlet,
to outlet,
even in
even
complex
in
or
complex
curved
or curved
geometries.
geometries.
These center
These
lines
center
provide
lines provide
significant
significant
utility in
utility
several
in
ways.
several ways.
First,
First,
they
they
represent the true
represent the
flow
true flow
direction,
direction,
which is vital
which is
for
vital for
computational fluid
computational fluid
dynamics
dynamic
simulation.
simulations.
Second,
Second,
they help
they
define
help define
path-based
path-based
measurements,
measurements like
vessel length,
vessel length,
meteoricity,
meteoricity,
and curvature.
and curvature.
Third, they are
Third,
critical
they are
for mesh
critical for
clipping,
mesh clipping,
especially
especially
generating
generating
inlets
inlets
and
and
outlets
outlets
that are
that are
orthogonal to the
orthogonal
vessel
to the
axis.
vessel axis.
The
The
benefit of
benefit
using
of
center
using
lines
center
is
lines
that
is that
they reduce
they
the 3D
reduce the 3D
complexity of a
complexity of
vessel
a vessel
into a
into a
manageable 1D
manageable 1D
representation without
representation
using
without
special
using special
effects.
effects.
You can
You can
overlay them
overlay
onto the
them onto
original
the
3D
original
views
3D
to
mask to
visualize flow
visualize flow
trajectories
trajectories or
or
use
use
them
them
as
as guides
guides
for
for
simulation.
simulation.
Boundaries
Boundaries
extend
extend
deployment paths
deployment
or
paths
even
or even
catheter treatment.
catheter.
Simpleware
Simpleware
also allows
also allows
centerline-based
centerline based
skeletonization,
skeletonization,
enabling you
enabling
to
you to
break down
break down
complex
complex
transient
transient
networks
networks
such
such
as
as
coronary
coronary
cerebral arteries
cerebral arteries
into
into
individual
individual
paths for
paths
detailed
for
analysis.
detailed analysis.
You can
You can
export these
export these
centerlines
center
as
lines
CSV
as CSV
files,
files,
SQL center
SQL
paths,
center paths,
or even
or
use
even
them
use
as
them
inputs
as
for
inputs for
simulation
custom
environments.
simulation environments.
They are
They
also
are also
invaluable
invaluable
in
in
constructing
constructing
stand
stands,
geometries,
geometries,
where the
where
stand
the
needs
stand
to be
needs to be
conformed
conformed
along a
along a
curved artery.
curved artery.
In the following
In the
slides,
following slides,
we'll see
we'll see
how
how
edit
edit
define
define center lines.
So once the
So once the
arterial center
arterial
lines
center
are
lines are
generated, the
generated,
next
the
step is
next
to
step is to
prune
prune
and edit the
and
center
edit
line
the center
to remove
to
any
remove any
irrelated
irrelated
or
or
extraneous
extraneous
branches.
branches.
This
This
refinement
refinement
ensures that
ensures
only
that only
clinically
clinically
or
or
simulation relevant
simulation
parts
relevant parts
are retained,
are retained,
improving both
improving both
visual and
visual clarity
downstream
and downstream modeling
accuracy.
accuracy.
In
In
cardiovascular scans,
cardiovascular scans,
especially those
especially those
involving
involving
complex networks
complex
like
networks like
coronary tree
coronary
or
tree
aortic
or
arch
aortic arch
branches,
branches,
it's common
it's
for
common for
automatic
automatic
centerline
centerline
extraction
extraction
to pick
to
up
pick up
tiny
tiny
disconnected or
disconnected or
unnecessary side
unnecessary
branches.
side branches.
While these
While
might be
these might
part
be
of
a part
image
of
data,
image data,
they often
they
don't
often don't
contribute
contribute
meaningfully
meaningful
to
to
simulation or
simulation or
design.
design.
Simpleware allows
Simpleware
you to
allows you to
automatically or
automatically or
manually prune
manually
these
prune these
unnecessary
unnecessary
branches.
branches. The
Automatic
automatic
methods
methods
use
use
defined threshold
defined
for
threshold for
minimal branch
minimal
length,
branch length,
branching angle,
branching
and
angle,
connectivity
connectivity
measurements.
measurements.
Alternatively, you can
Alternatively, you
perform
can
manual
perform
pruning
manual pruning
using the 3D
using the
view.
3D view.
Simply select
Simply
the
select the
unwanted branches
unwanted branches like those
leading
leading
to
to
small
small
peripheral
peripheral
vessels
vessels
and delete
and
them with a
delete
click.
them with a click.
This
This
hands-on control
hands-on
is
control
valuable
is valuable
when
when
working
working
with
with
patient-specific
patient-specific
tasks,
data,
where
where
anatomical
anatomical
variations
variations
may require
may require
subjective
subjective
decision-making.
decision making.
Why is this
Why
step
is this
important?
step important?
The clean
The
center
clean
line
center line networks
improve
improve
computational fluid
computational
dynamic
fluid
mesh
dynamic
quality
mesh
by
quality by
mesh
reducing mesh
clutter,
clutter,
focus
focus
simulation
simulation resources
major
on
flow
major
paths,
flow paths,
enhance
enhance
readability
readability and
and
interpretability of
anatomical maps,
anatomical maps,
allow more
allow more
efficient 3D
efficient
printing
3D
for
printing
stand
for
planning
stand
by
planning by
focusing on
focusing on
primary
primary
vessels.
vessels.
You can
You can
also
also
assign
assign
labels or
labels or
classification to
classification
retained
to
branches,
retained branches,
example left
example left
anterior,
anterior,
descending artery,
descending
or
artery or
ascending aorta,
ascending aorta,
which is
which is
especially useful
especially
for
useful for
structured
structured
reporting or
reporting or
automated simulation
automated simulation
workflows.
workflows.
Summary
Summary
pruning
pruning
and editing
and
center
editing
line networks
centerline
is a
networks
vital
is a vital
post-processing step.
post-processing step.
Trans-
Trans-
Transition your
Transition
data
your
from
data
raw
from
geometry
raw
to
geometry to
fine
fine
simulations,
simulations
ready
ready
vascular
vascular
manual
manual
centerline cleanup
centerline
in
cleanup
3D
in
view.
3D
In
view.
addition
In
to
addition to
automatic pruning,
automatic pruning,
Simpleware offers
Simpleware
a
offers a
powerful feature
powerful
for
feature
manual
for manual
centerline cleanup
centerline
in
cleanup
3D view.
in 3D view.
This tool
This
provides
tool
high
provides
level
high-level
control,
control,
allowing
allowing
users to
users to
fine-tune vascular
fine-tune vascular
centerline
centerline
networks by
networks by
directly
directly
interacting with the
interacting
3D
with the
geometry.
3D geometry.
When you
When
switch
you
to
switch
3D
to
view with
3D view with
centerline displayed,
centerlines displayed,
each node and
each node
segment
and
becomes
segment
selectable.
becomes selectable.
This
This
enables
enables
users to
users
visually
to
inspect
visually inspect
entire
entire
networks and
network
delete
and delete
specific
specific
nodes or
nodes
vessel
or vessel
paths
paths
that are
that are
enormous,
enormous,
overly
overly
complex, or
complex, or
clinically
clinically
irrelevant.
irrelevant.
This
This
functionality
functionality is
special
special,
useful in
useful in
scenarios like
scenarios like
removing
removing
centerline
centerline
fragments,
fragments in region with
imaging noise or
imaging noise or
segmentation
segmentation
artifacts,
artifacts,
trimming of
trimming
distal
of
branches
distal
of
branches of arteries that are not part of
scope,
analysis scope,
defining
defining
overlapping paths
overlapping
in
paths
torches
in
or
tortuous or
bifurcated
bifurcated
vessels with
vessels with
Automatic
Automatic
cloning may
cloning
struggle.
may struggle.
You can
You
zoom
can
into
zoom into
problem
problem
areas,
areas,
rotate the
rotate the
model,
model,
and select
and
single
select single
segments or
segments
entire
or
branches
entire
for
branches for
deletion or
deletion or
modification.
modification.
The
The
interactive nature
interactive
of this
nature of
cleanup
this cleanup
process,
process,
given users
given users
complete
complete
control
control
over the model,
over model,
ensures the
ensures
final
the
center
final
line
center line
reflects true
reflects true
anatomical value.
anatomical relevance.
In
In
cardiovascular
cardiovascular
simulations,
simulations,
this step
this step
enhances
enhances
simulation
simulation
accuracy,
accuracy,
ensuring correct
ensuring
flow
correct flow
paths.
paths,
Stand and
stand
graph
and
planning,
graph planning,
where device
where
geometry
device geometry
depends on
depends
clean
on clean
trajectories.
trajectories.
Visual
Visual
clarity,
clarity,
which helps
which
in
helps in
creating
creating
educational or
educational or
presentation quality
presentation
images.
quality images.
In addition
In
to
addition
deletion,
to
you
deletion,
can
you can
also
also
adjust node
adjust node
position,
positions,
extend or
extend
reconnect
or reconnect
branches, and
branches,
even
and even
split or
split
merge
or
segment
merge
if
segment
needed.
if needed.
In summary,
In summary,
manual 3D
manual
center
3D
line cleanup
centerline
is an
cleanup is an
essential
essential
finishing step
finishing step
for high
for high
fidelity vascular
fidelity
models,
vascular models,
especially in cases
especially in cases
involving
involving
complex or
complex or
custom patient
custom
anatomy.
patient anatomies.
Ensures your model
Ensures
is
your model
not just
not just
anatomically
anatomically
correct,
correct,
but also
but also
simulation ready
simulation
device,
ready device,
compatible and
compatible
visually
and visually
optimized.
optimized.
Next, we'll look
Next, we'll
how
look
color
how
mapping
color
of
mapping
node
of node
connectivity further
connectivity further
enhances
enhances
interpretation of the
interpretation of the
centerline structure.
centerline structure.
Following manual
Following manual
centerline cleanup,
centerline cleanup,
an
an
excellent way to
excellent way to
visualize,
visualize,
validate, and
validate, and
interpret the
interpret the
vascular network
vascular
is
network
through
is
color
through
mapping
color
of
mapping
node
of node
connectivity.
connectivity.
This feature
This
is
feature is
simpleware
simpleware
provides a
provides
fast and
fast
intuitive
and
method
intuitive
to
method
analyze
to analyze
topology of
topology of
centerline
centerline
networks,
networks
assigning
by
color
assigning
based
color based
on node
on
style,
node type
and connectivity.
and connectivity.
Each node or
Each
point
node or
along the
point along the
centerline is
center line is
classified as one
classified
of the
as one
following:
of the following:
root nodes,
root nodes,
start points of
start
vessel
points of
trees,
vessel trees,
junction nodes,
junction nodes, bifurcation of
bifurcations,
bifurcations,
leaf nodes,
leaf
endpoints,
nodes,
or terminal
endpoints, or
branches.
terminal branches.
These are
These
color
are
coded
color coded
in
in the
3D views.
3D viewers.
For example,
For
blue or
example,
root
blue or
nodes,
root nodes,
yellow or
yellow
green
or
for
green
functions,
for functions,
red or
red
blue
or flea
for nodes.
for nodes.
This visual
This
map
visual
allows
map
users
allows
to
users
quickly
to quickly
identify
identify the structure
and
and
complexity of the
complexity of
vascular
the
tree.
vascular tree.
You can
You can
immediately spot
immediately
if
spot
a vessel
if a vessel
incorrectly
incorrectly
terminates early,
terminates early,
missing
missing
continuation,
continuation,
or
or
if a
if
junction
a
is
junction is
misrepresented,
misrepresented,
extra or
extra
missing
or
branches.
missing branches.
Such
Such
insights are
insights are
particularly useful
particularly
when
useful
working
when
with
working
branching
with branching
structures
structures
like
like
coronary
coronary
arteries,
arteries,
renal
renal
arteries, or
arteries, or
intracranial
intracranial
vasculature,
vasculature,
where flow
where
paths,
flow paths,
symmetry, and
symmetry, and
bifurcation rules
bifurcation
are
rules
vital
are
for
vital for
simulation
simulation
and
and
device design.
device design.
In research
In
or
research or
regulatory
regulatory
documentation,
documentation,
color-coded
color-coded
centerline
center
networks
lines
are
makes the anatomical modeling
transparent and
transparent
easy to
and easy to
interpret.
interpret.
It
It
also helps
also
in
helps in
presenting results
presenting
to
result to
multidisciplinary
multidisciplinary
teams,
teams,
including
including
biomedical
biomedical
engineers,
engineers,
simulation
simulation
experts,
experts, and
regulatory
regulatory
reviewers.
reviewers.
Moreover, these
Moreover,
maps
these
can
maps
guide
can
manual
guide manual
redefinement.
redefinement.
For instance,
For
if a
instance,
lead
if a
node
lead node
appears
appears
where
where
there should be a
there should
junction,
be a
it
junction, it
signals that
signals
branch
that a
might be
branch might
missing
be
or
missing or
incomplete.
incomplete.
To
To
summarize, color
summarize,
mapping
color
of
mapping
node
of node
connectivity
connectivity
transforms the center
transforms the
line
center line
from a
from a
geometric base
geometric base
into a
into a
functionally
functionally
informative
informative
network,
network,
enhancing both
enhancing both
quality
quality
assurance and
assurance and
communication across
communication
teams.
across teams.
After generating
After
and
generating and
refining
refining
centerline networks,
centerline
one of the
networks, one of
most
the
valuable
most valuable
processes you can
processes you
perform
can
is
perform
measuring
is
the
measuring
length
the
and
length
stack
and
lengths
stack
of these
of
center
these
lines.
center lines.
This data
This
is
data is
essential for
essential
vascular
for
device
vascular
planning,
device planning,
computational
computational
simulation, and
simulation, and
anatomical research.
anatomical research.
In simple
In
way,
simple way,
once center
once
lines are
center lines are
finalized,
finalized,
the software
the
can
software
compute
can
total
compute
path
total
length
path
of
length of
individual vessel,
individual vessel,
branch-wise length
branch
of
wise length of
multi-branch
multi
trees,
branch
total
trees,
aortic
total
arc,
aortic arc,
left common
left common
cardioid,
cardiotic,
on
on
left
left
subclavian
subclavian
arteries.
arteries.
Cumulative lengths
Cumulative
across
lengths
the
across the
entire center
entire
line,
center line network.
ketosity
Ketosity
metrics, which
matrix, which
indicates how
indicates
much a
how much
vessel
a
curves
vessel
or
curves
coils.
or coils.
These values
These
are
values are
displayed in
displayed
tabular
in
format
tabular format
and can be
and can be
exported
exported
as CSV
as
files
CSV
for
file for
documentation,
documentation,
regulatory
regulatory
submission, or
submission, or
post-processing.
post-processing
In software
in
like
softwares like
Excel,
Excel,
MATLAB, or
MATLAB,
Python.
or Python.
So, in
So,
muscular
in
standing,
vascular stenting,
accurate
accurate
measurements of
measurements
vessel
of
length
vessel length
ensures the
ensures
stand
the stent
or
or
graft
graft
covers the
covers
required
the required
anatomical zone
anatomical
without
zone without
overextension.
overextension.
In
In
conventional fluid
conventional
dynamics,
fluid dynamics,
path length
path length
affects flow
affects flow
resistance
resistance
and shear
and
stress
shear stress
distribution.
distribution.
Additionally, these
Additionally,
measurements
these
are
measurements
critical
are
when
critical when
comparing
comparing
anatomical
anatomical
models.
models.
Pre and post
Pre and
surgical
post
changes
surgical
in
changes,
normal versus
normal versus
deceased
deceased
anatomy,
anatomy,
adult
adult
vasculature.
vasculature.
Statistical
Statistical
summaries
summaries like
mean, median,
mean,
minimum,
median, minimal,
and
and
maximum
maximum
branch
branch lengths
also help
also help
standardize studies
standardize
across
studies across
populations
populations
or
or
clinical
clinical
cohorts.
cohorts.
They can
They
assist
can
in
assist in
designing
designing
size-specific
size-specific
devices,
devices,
building
building
parametric
parametric
or
or
simulations.
simulation.
In
In
educational and
educational and
presentational
presentational
contexts,
contexts,
these
these
quantified
quantified
insights
insights
transform
transform
anatomical
anatomical
images into
images into
data-driven
data-driven
tools,
tools,
making
making
interpretation
interpretation
more
more scientific
scientific.
and actionable.
In summary,
In summary,
centerline lens
centerline
and
lens and
statistical
statistical
elevate
analysis
the
elevate
3D
the
model
3D model
from a visual
from a
tool
visual
to
tool to
quantitative
quantitative
framework,
framework,
one that
one
supports
that supports
precision
precision
medicine,
medicine,
regulatory
regulatory
compliance, and
compliance, and
evidence-based design.
evidence-based design.
Next, we'll
Next,
explore
we'll
how
explore how
analyze
analyze
cross-sectional
cross-sectional
area along
area
vessel.
along vessels.
Another key
Another
feature
key
for
feature
sizing
for sizing
implants is
implants is
evaluating
evaluating
stenosis.
stenosis.
After evaluating
After evaluating
centerline,
centerline lines,
the next key
the next
metric
key metric is the
cross-sectional area
cross-sectional
along the
area
length
along the length
of the vessel.
of a vessel.
This type of
This type of
analysis
analysis
is
is
indispensable in
indispensable in
understanding
understanding
luminal variation,
luminal variation,
identifying
identifying
stenosis or
stenosis
dilation,
or dilation
and sizing
in
vascular
sizing vascular
implants
implants
such
such
as
as
stents or
stents or
grafts.
grafts.
In simple
In
way,
simple
once
way, once
centerlines are
center lines are
completed,
completed,
cross-sectional planes
cross-sectional
can be
planes can be
automatically
automatically
generated
generated at
at regular
regular
intervals
intervals
orthogonal to vessel
orthogonal to vessel
paths. The
paths.
software
The
then
software then
calculates the
calculates
minimum,
the
maximum,
minimum, maximum,
and mean
and mean
areas of these
areas of
slices
these slices
and presents
and
them
presents
as
them
both
as
visual
both visual and
overlays and
overlays in
quantitative.
quantitative data.
Area plots
Area
allow you
plots
to
allow you to
identify
identify
critical narrowing
critical
where
narrowing
stent
where
may be
stents may
required.
be required,
Measure a
measure a
uniformity of
uniformity of
vessel
vessel
diameter.
diameter,
Design
design
implants that
implants that
conform
conform
to patient
to
specific geometry.
patient-specific geometry.
This
This
data is
data is
essentially
essentially
useful
useful
in
in
simulation
simulation
workflows. For
workflows.
example,
For
flow
example, flow
restriction
restriction
points
points
are often
are often
correlated with
correlated
high
with
volume
high
shear
volume shear
stress
stress
in conventional
in
fluids
conventional fluids
dynamic
dynamic
studies,
studies,
which could
which could
indicate
indicate
areas of
areas
risk
of
for
risk for
thrombosis or
thrombosis or
restenosis.
restenosis.
Additionally, in
Additionally, in
device
device
research and
research and
development,
development,
cross-sectional
cross-sectional
analysis helps
analysis
validate
helps
that
validate
an
that an
implant
implant
will maintain
will maintain
competency across
competency across
anatomical
anatomical
variations.
variations.
Supported data
Supported
can be
data
used
can be
to
used to
design custom
design custom
scaffolds,
scaffolds,
balloons,
balloon
guides.
profiles.
You can also
You can
visualize
also
the
visualize the
as a
areas as a
continuous
continuous
area
area
profile
profile plot
along with the
along
vessels.
with the vessel.
Diameter and
Diameter
radius
and
extraction
radius
via
extraction
best
via
fit
best fit
circles beyond
circles
area
beyond area
analysis.
analysis. Simple way also
Upper
allows
diameter
upper
and
diameter
radius
and radius
extraction
extraction
using best
using
fit
best fit
circles
circle
based on
based
each
on each
versus
vessel's
cross section.
cross section.
This tool
This tool
translates area
translates
metrics
area
into
metrics into
standardized diameter
standardized
values,
diameter values,
which are
which
easier to
are easier to
interpret
interpret
and more
and
directly
more directly
applicable for
applicable
device
for
selection.
device selection.
Best fit
Best fit
circles are
circles are
calculated for
calculated
each
for
slice
each slice
along the
along the
vessels
vessels
overlaid
overlaid
on the 3D
on the
model.
3D model.
The result
The
is
result is
profile
profile
on how
on
the
how
diameter
the
changes
diameter
along
changes
the
along
length
the
vessel.
length vessel,
Particularly useful
particularly
when
useful
used
when
for tapered
tapered
focal
geometries,
stance.
focal stance.
With this
With this
information,
information,
clinicians
Kenyans
and
and
engineers
engineers
identify narrowest
identify
point
narrowest point
for stand
for stand
deployment,
deployment,
planning landing
planning
zones
landing
where
zones where
stands
stands
can
can
be
be
anchored,
anchored,
detect
detect
diameter
diameter
that may
mismatch that
cause
may cause
flow
flow
disturbance.
disturbance.
Tool ensures
Tool ensures
quantitative
quantitative
precision
precision
while
while
maintaining
maintaining
anatomically
anatomically
accuracy
accuracy and is
and
compatible
outputting
output
excellent
Excel,
CAD and
CAD,
mesh
or mesh structure.
background volume
Background
rendering
volume rendering
techniques
techniques
allows you to
allows you to
visualize
visualize
3D
the 3D
anatomy
anatomy
while
while
preserving
preserving
contextual
contextual
grayscale detail.
grayscale detail.
This is
This is
especially
especially
helpful
helpful
when
when interpreting
vascular
vascular
paths
paths
in
in
relation to
relation
bones,
to bones,
muscles,
muscles, or
surrounding tissue.
surrounding tissue.
Simple way
Simple way
supports
supports
multiple rendering
multiple rendering
styles
maximum intensity projection for highlighting dense structures like calcifications, alpha blending for semi-transparent overlay, multi-channel fusion for overlaying segmentations with original grayscale. Volume blending provides a comprehensive 3D view of anatomy and is often used for reporting or clinical presentation. These tools allows user to draw line across an image slice and view grayscale intensity profile. It is particularly useful for refining segmentation thresholds by identifying where pixel values shift across tissue boundaries. This analysis helps tune segmentation thresholds, evaluate transition zones, for example, blood tissue interfaces, detect partial volume effects, image artifacts. Now, region growing is a segmentation enhancement that expands a selected voxel regions based on intensity similarity and connectivity, ensures anatomical continuity, and improves segmentation accuracy, especially in tabular structures like arteries. This method is often paired with blood fill thresholding, is helpful when working with heterogeneous intensities. 3D editing to remove artifacts. Following segmentation, some artifacts may remain. Simpleware allows manual 3D editing using tools like 3D paintbrush, 3D lasso tool, Boolean subtraction, volume cropping, and trimming. These tools ensure final model is clean and simulation ready. Probing specific vessel points for geometry. A single click along a center line gives detailed geometry info, area parameter, and encircles at the point. It's useful for localized analysis. Now let's come to Gaussian smooth and final model refinement. So it is a recursive Gaussian filter that smooths surfaces, reducing jagged edges and enhancing mesh quality. It is used for binarization for best results. Computational fluid dynamics for boundary condition assignment. It defines inlet, outlets, and wall conditions for fluid simulations. Accurate boundary setup is crucial for meaningful computational fluid dynamics results in vascular flows. Now creating computational fluid dynamics model from segmented vessels. So segments mass are converted into computational fluid dynamics models for simulation and model settings like finite element analysis, free meshing, and fluid domain assignments are configured. So computational fluid dynamics meshes while using clipping planes for custom planes based on centerline clip vessels create flat inlets, outlets. These improve mesh quality and allow simulations away from image edges. So now comes automated solutions. So uh, as we studied earlier in the past lectures about automated segmentation of orthopedics, we have automated segmentation of cardiovascular also. This consists of heart CT or pulse analysis, which we have discussed in the earlier slides. Also, we can use custom modeler, which is used in various versions of this software. That's image processing, landmarking, measurements, statistics, and reports. Model meshed and ready for 3D printing and CAD simulation. Now, automated solution models of this simple way softwares. So, how it is used? 3D image processing for life sciences with machine learning. Simple automated solutions are powered by AI and technology using machine learning algorithms. It is a laborious process that occupies significant engineering resources and time, can now be completed quickly. Like if a task can be completed in manual segmentation in 1 hour, the auto segmentation will take only 1 minute to complete the task and segmentation. So the technology also dramatically streamlines the processing of large data batches in both research tools and medical devices, reducing time on manual processing fees, engineering time for more complex and higher value risks. So in simple way, anatomy specific mathematics segmentation for hearts, we can see this is how like auto segmentation works. Segmentation blood pool cavities and selecting muscle tissues as well as identifying common key landmarks. Heart segmentation from CT scans includes left atrium, right atrium, ventricles, left ventricle, right ventricle, aorta, pulmonary artery, and myocardium. Landmarks placed on aorta and left ventricles. So why we use, as we discussed earlier, so uh, in orthopedics, the manual segmentation time is less, but when we segment a heart, it takes around for an expert it takes around 4 hours. But when we use automated segmentation, it takes around 1 minute and 5 seconds. So that is how it is really essential and helpful. So you can see this is the final product that is in 3D printed. It has slices. This is all the part of a heart. We can see any tumor or any disease in this 3D printed product. So that is how layers slices works in this 3D model. So it has many slices. So slices helps in seeing the model in the interior view. So by which we can uh, deeply diagnose any disease or tumors or any simulation. So next we will see the demonstration of this cardiovascular applications in 3D modeling in the Synopsys Simpleware software at 2:30 p.m. I hope everyone will be there. If there is any questions for me, you can ask, or you can WhatsApp me, email me, or call me directly for any queries related to the applications or Synopsys Simpleware software. Yes, sure. These all sessions are recorded, and we'll share the recorded lectures with you. So I guess there are no queries. Uh, so thank you for attending the session. See you soon in the afternoon session. That is from 2:30 p.m. We'll see the demonstration there.
Thank you all.
Thank you all.